Welcome to our comprehensive installation guide on setting up a robust 1 kVA transformer-based inverter system with an inbuilt PWM charge controller. This cutting-edge system combines 6 high-performance 180-watt solar panels and 2 long-lasting 220 amps tubular batteries to provide a reliable and efficient source of renewable energy for your homes or offices. This installation comprises of the following key components: 1 kVA transformer-based inverter with inbuilt PWM charge controller, 6 pieces of 180-watt solar panels for maximum energy generation, 2 pieces of 220 amps tubular battery for extended power backup, a voltage regulator for a stable power input, DC source protector for system protection, and a roof-mounted profile for secure panel installation. In this installation guide, we will walk you through the step-by-step process of setting up your 1 kVA transformer-based inverter system. From preparing the site to connecting the components, we will cover everything you need to know to get your system up and running. Stay tuned for a brighter, more sustainable future.
Okay, so I'm on the roof now trying to set up my panel. So as you can see, these are my interlock for otherwise known as a panel rack. They are all set. Let's stop the panel setup. So what I did was to parallel all the panels together. What I mean by parallel is just putting the positive wires and the negative wires separately. Like you see, this is the first panel here, and this is the positive, and this is the negative, one side. I did the same to the second panel. This is the negative, and this is the positive. I did the same with the third. This is the positive, and this is the negative. I did the same with the fourth and the fifth. These are the positive, and these are the negative. I did the same with the last, which is this one. This is the positive, and this is the negative, and this is the DC cable that went inside the room. I'll be connected to the inverter. Like you see, I'm done with my connection already, so I just have to make these videos for you guys to understand it better. So what I just did is called parallel connection. All the positive terminals are connected in one wire, which is this. These are the negative. All the terminals are connected on this black wire, and the positive of each of the panel are connected on this wire here, on this DC cable. So as you can see, I'm done with my connection, and these are the arrangement of my panel. So I'm done up here. I'm heading down now for my indoor connection, the installation of the battery, the inverter, and the connection, the AC inputs, the AC output, the inverter output, and the rest.
Okay, on the box, we have our DC source protector and our voltage regulator. This is the SPDC DC source protector, and the blue wire is the positive terminal from the panel, and the black wire is the negative terminal from the panel. And this one is going straight to the inverter, the PWM charge controller to the inverter. That is the ground, which one is going to the DB, and the other one is going to the inverter. This is the voltage regulator, and that is the AC input. That is the main source line, the life and the neutral line. The red wire is the lifeline, and the black wire is the neutral line. From there, I connected it to the voltage regulator. I connected to the voltage regulator from there. That is the AC input. which actually protects the inverter. That is the AC input, that is the AC output. This is the neutral line, and that is the lifeline. So these three is going to the inverter. The red, green, and black, which is neutral, life, and ground. That is the AC input, the life, and that is the DC cable. This is the negative, and this is the positive. This is where the panel DC cable will be terminated to positive, negative to negative. That is where my load will be connected, life and neutral, and that will be where the inverter output will be connected to. That's my German changeover, and that's a 4-way breaker box with a DC source protector and a voltage regulator inside. Then we have our 2 pieces of tubular battery and the battery rack itself. We have our 1 kVA transformer based hybrid inverter system. Okay guys, so I've brought out all the wires for the connection. This is the AC output, and this is the AC input. This is the inverter output. That's the wire that will be connected to the inverter. This is my load line that will be terminated on the DB, where the selected load will be connected to. This is the load line. This is the inverter output. This is the AC input. This is the AC output. This is the SPDC. This is the ground. This is the positive and the negative. This is where the wire will be terminated from the roof, and this particular one is going straight to the inverter. And this is the battery that I'll be installing today. So this was how the whole connection looked like when we were done with the whole installation. The 2 batteries were being parallel together because the 1 kVA transformer based inverter we used was a 12 volts transformer based inverter precisely, and all the connections I showed you earlier, as you can see on the video where our voltage regulator and our DC source protector is, the whole connection went straight to the inverter. On the inverter body, you will see where the road PV positive and PV negative is very simple and very easy to understand. And we have the AC input, which was connected from the voltage regulator to the inverter itself. So that was just the whole basic connection. And up there we have our 6 pieces of 150-watt solar panel connected in parallel. All of them were connected in parallel. None of it was series. All of them were connected in parallel. Reason being that we used a transformer based inverter with an inbuilt PWM charge controller. Okay guys, so the diagram on the screen shows you a brief explanation on how to install any kind of inverter system either in your home, offices, or business places. So let's start with the first box there where they wrote AC input. So the AC input, under it we have our E, L, and N. Our E there is known as the ground, and the L there is known as the life, and the N there is known as the neutral line. So the E is either green wire or yellow wire. Our L is always red wire or ox blood, depending on the country where you're watching from. Then our N is either black or blue in most countries, but it's mostly black. So on my AC input on this video, my AC input was being connected from the up of the changeover, which was tapped from the building, from the AC line of the building, which is still known as grid line. Either you know it as AC line or grid line. So it's connected from the distribution box of the building down to the up of the changeover. Then from the changeover, I tapped on the changeover down to the voltage regulator. L to L, which is live, N to N, which is neutral. Then on the out of that voltage regulator was being connected to the inverter itself. So the next box there is our AC output, which is the inverter output. So it's being connected to the down of the changeover, which is known as the AC output. Still Here we have our E, which is known as the ground, and we have our N, which is known as the neutral, and we have our L, which is known as the lifeline. Then our PV line, we have the minus and plus, which is known as negative and positive. So all the panels that were parallel together, the negative terminals was being connected on the negative line, which is the black line that you're seeing here, and the positive was being connected on the red circuit line that you're seeing on the diagram on the screen here. So that's just it. Then for the battery, we have the minus and plus, which is known as the negative and positive. Okay, mind you, when you come to DC, what we have is negative and positive, and when you come to AC, alternating current, what we have is life and neutral. Please bear this in mind. For AC, we have life and neutral, and for DC, we have positive and negative. I think with this whole diagram, it's very, very easy for you to understand the whole, or for you to understand how the whole connection was being carried out, from the AC input down to the AC output, down to the PV input and the battery terminals, both positive and negative. Thank you guys, and please don't forget to like, comment, subscribe, and share for more videos.